Hi, welcome to our course on web application development. Before we dive into ASP.NET MVC, let's understand what web applications are. A web application is a software that runs on a web server and is accessed through a web browser over the internet or an intranet. In my speaking, I identified a web application by three components. We have a server and we have a web server, something like Windows Server or Linux Server or something like that. We have a browser like Mozilla or Internet Explorer, Firefox or something like that. And we have a protocol that used to communicate information between the server and the client, and that could be HTTP or HTTPS protocol or something like that. And we call this protocol Internet or Intranet protocol. Unlike desktop applications that must be installed on each user's computer, web applications are centrally hosted and acquire no installation. This means if you want to use Microsoft Office as example, you need an installation or a setup to download the files and install them on your Windows application. And we have different versions of Office that are compatible with the operating system that you use. And this complicates the publishing of the system. For that reason, web applications can be better in this case because the software itself, the system or the web application is stored and hosted in the web server. And the client, the person who is going to use it, doesn't need to install any additional software or files on his machine. They can access the system through the web browser. Users simply navigate to a URL to access the application. This offers several advantages. Automatic updates for all users, cross-platform compatibility. What does it cross-platform compatibility? This means the system works on Windows, Mac, Linux, mobile devices, or whatever. Any system that can display HTML pages can work your system almost. And finally, the accessibility from anywhere with an internet connection. For that reasons, we can find web applications are more common these days than the desktop applications. Think about applications like Gmail, Facebook, or even an online banking. These are all web applications that are accessed through your browser rather than installing dedicated software on your device. Now, as you understand what is a web application, let's see the architecture behind the web application. Okay? Web applications typically follow a client-server architecture. This model involves three main components. First, we have the client tier. Okay, let's start from the client tier. This one, the first one. Okay, first we have the client tier, which is typically a web browser that sends requests to a server. Okay, it's the request that sends requests to the server. Okay, like this arrow. This is the presentation layer that the user interacts with usually. When you use any web application, you only need to find the browser and interact with the browser. No need to know anything about the server side. The second component in this architecture is the server, called the server tier, contains the application logic. When the web server receives a request, it processes it, executing the application code that originally hosted on the server to generate something we call a response and send that response back to the client. This is where frameworks like ASP.NET MVC operate. They works here in the server, okay? They receive the input or whatever the client requested, they make some processing and return back the response. The third part of the architecture is the database tier. Database tier stores and manages the application's data. The server communicates with the database to retrieve or update information based on the user's requests. For example, when you log into a social media site, your browser, which is the client, sends a request to the server. The server, in his turn, verifies your credentials against the database. When we say verify, it's going to check to retrieves your feed data, processes processes it and sends back an HTML, CSS, and some JavaScript back again to the browser to render them. Okay, this separation of concern makes web applications more scalable, maintainable, and secure. Each layer can be optimized, scaled, and replaced independently. Okay. Now let's speak a little bit about the history. Web applications have evolved dramatically over the years. In the early days of the web, known as Web 1, sites consisted primarily of static HTML pages with minimum interactivity. They have only hyperlink to click, nothing else. There is no buttons, no forms, no validation, no menus, and so on. These sites were essentially digital brokers where information flowed in one direction from the server to the user. The user do not interact a lot. The server only hosts some static HTML files and the browser bring them to display and render them to the end user. And that's all. After that, with Web 2, after that, with Web 2 in 2000s, we saw the emergence of dynamic content and greater user applications. Technologies like Ajax allowed for synchronous data loading without page refreshes, creating more interactive experience. This era gave birth to social media platforms, wikis, blogs, and other web systems. Okay, let's speak a little bit about Ajax. In Web 1, if you need to change anything in the page, you have to click a hyperlink and make a refresh for the page. This means to reload the page again from the server to the client. When they invented the concept of Ajax, okay, it's a synchronous JavaScript call. This means I can make a call to the server and bring some partial response, something like a small view or a small table or some data, and display them and manipulate them in the client instead of refreshing the application. Look at that like someone who posted something on Facebook, and when you scroll down, you have that post immediately on your wall without refreshing or reloading or reopen the Facebook app again in your browser. Today's modern web applications are characterized by responsive design that adapt to different screen sizes, from desktop to smartphones. And we have something called single page applications, SPAS. Load a single HTML page. It's only one single HTML page and dynamically update contents as users interact with the app, providing a more fluid user experience. And we have furthermore the progressive web applications offer offline functionality and app-like experiences in the browser. When we speak about single page applications, we are speaking about applications that made with something like Angular, Vue, React. They only load once and start making everything using Ajax. Okay? And when we speak about PWAs, progressive web applications, we are speaking about things or applications or systems that can work offline and enable you to do some work offline. As example, Google Sheets can work offline and you can edit the sheet offline. Once you are connected again, you can update your changes. Behind the scenes, many applications now use microservices architecture, not the architecture that I just explained uh, in the previous slide, where the application is divided into small independent services rather than built as a monolithic system. This allows for greater scalability and easier maintenance. ASP.NET MVC, which we will be studying in this course, fits into this modern web development landscape, providing a structured way to build scalable, maintainable web applications. Now, let's turn our attention to the HTTP protocol, which is fundamental to understanding web applications. HTTP stands for Hypertext Transfer Protocol, and it's the foundation of data communication on the World Wide Web. HTTP is a stateless protocol, which means each request response cycle is completely independent. The server does not maintain any memory of previous interactions with the client. This statelessness is important to understand because it creates challenges for maintaining user state across requests, leading to solutions like cookies, session storage, and tokens. In the HTTP model, communication is always initiated by the client, typically a web browser, but it could also be a mobile app or another service. The client sends a request to a server, and the server responds with the requested data or an error message. This request response model is the foundation of all web interactions. Even complex web applications with sophisticated user interfaces ultimately rely on this simple pattern of communication. Understanding HTTP is crucial for web developers because it affects everything from application design to performance optimizations and security implementations. Let's examine the HTTP request response cycle in detail. This process begins when a user takes an action in their browser, like clicking a link or submitting a form. First, the client, which is the browser actually, creates an HTTP request containing information like the URL, method type, headers, and possibly a body with data. This request is sent to the web browser. Second, the server receives this request and processes it. In an ASP.NET MVC application, this typically involves routing the request to the appropriate controller action, which may interact with a database or other services. Third, once processing is complete, the server generates as an HTTP response. This includes a status code indicating success or failure, headers with metadata, and the response body containing the requested data, often HTML, but also possibly JSON, images, or other formats. Finally, the client receives this response and processes it accordingly. For HTML responses, the browser renders the page. For API responses, the data might be processed by JavaScript code. This entire cycle happens with very interaction. This entire cycle happens with every interaction in a web application, even actions that seem instantaneous to users, like clicking a button or show a drop-down menu, may involve this full request response cycle. Although modern applications often use JavaScript to handle some interactions client-side without a round trip to the server. HTTP defines several methods, sometimes called verbs, that indicate the desired action to be performed on a resource. Let's look at the most important ones. Get is the first one. Get is the most common method used to request data from a server. When you type a URL in the browser or click a link, a GET request is sent. GET requests should only retrieve data and not modify any server state. Parameters are included in the URL and are visible to users. The second one is POST. POST is used to submit data to be processed. It's commonly used for form submission. that create new records. Unlike GET, post data is included in the request body, not the URL, so it's not visible in the browser address bar and has no size limitation. The third verb is put. Put is used to update an existing resource. It replaces the entire resource with the data sent in the request. For example, updating a complete user profile would use put. Delete. Delete, as the name suggests, removes the specified resource. It's used when you want to delete data from the server. There are other methods like patch or for partial update. Head to retrieve just the headers without the body, and options, which returns the HTTP method supported by the server. In ASP.NET MVC, these HTTP methods are mapped to controller action methods using attributes like HTTP GET, HTTP POST, etc., which we all see in more detail later in the course. HTTP status codes are 3-digit numbers that the server includes in responses to indicate the outcome of a request. They are grouped into 5 categories. 1XX codes are informational and indicate that the request has been received and the process is continuing. These are relatively rare in everyday web development. The 2XX codes indicate success. The most common is 200 OK, which means the request was successfully and the response contains the requested data. 201 created is used when the resource has been successfully created, like after a success post request. 204 means no content, indicates the request was successfully, but there is no content to return. The 3XX codes indicate redirection. 301 means moved permanently, and 302 found temporarily redirected. Tell the client that the resource has moved to a different URL. 4XX codes indicate client errors. 400 bad requests means the server couldn't understand the request due to bad syntax. 401 unauthorized means authentication is required. 403 forbidden means the client does not have permission to access the resource. 404 not found is the most famous one. The requested resources does not exist. 5XX codes indicate server errors. 500 internal server error is the generic server error message. 503 service unavailable means the server is temporarily unavailable, often due to maintenance or overload. In ASP.NET MVC, you will work with these status codes when creating controller actions, especially when handling errors or implementing security. The HTTP headers and content types. HTTP headers provide additional information about the request or response. They are key value pairs sent along with the HTTP request or response. Request headers are sent from the client to the server. The user agent header identifies the browser or application making the request. The user agent header identifies the browser or application making the request. Accept tells the server what content types the client can handle. If you are submitting data, content type specifies the format like form data or JSON. Authorization header carries credentials for protected resources. The cookies headers sent send stored cookies back to the server. Response headers come from the server to the client. Content type tells the browser what kind of data is being returned, like HTML, JSON, or an image. Content length indicates the size of the response body. Set cookie instructs the browser to store cookie for future requests. Cache control provides a directive on how the response should be cached. MIME types, multi-purpose internet mail extensions, identify the format of the content. For example, text HTML is for HTML documents. Application JSON is for JSON data. Image formats have types like image, JPEG, and application PDF is for PDF documents. In ASP.NET MVC, most header handling is done automatically, but you can explicitly set headers when needed. For example, you might set content type to application JSON when returning JSON data from an API endpoint. Understanding headers is crucial for handling authentication, caching, content negotiation, and troubleshooting web applications. Let's look at a concrete example of HTTP communication to solidify our understanding. Here is a typical HTTP request, and this is the request. Okay? This indicates, let's look at the beginning in the request. See the get at the beginning. We have get. Okay? Dash products, question mark, category equal, electronics, HTTP1, and so on. This indicates it's a GET request to retrieve products in the electronic category. The host header, the next one, the host header specifies the domain, while user agent identifies the browser. The accept header indicates the client can process HTML content, and cookie sends stored cookies from previous interactions. The server response on the other side with HTTP 1.1 200 OK indicating the request was successful. Content type tells the browser it's receiving HTML content encoded in UTF-8, and content length specifies the size of the response in bytes. The date header shows when the response was generated. Following the headers is the actual HTML content of the page that will be rendered by the browser. When developing with ASP.NET MVC, you won't usually see the raw HTTP messages as shown here, but the framework processes them behind the scenes. Understanding these communications help you troubleshooting issues, optimize performance, and implement security features correctly. For example, in an ASP.NET MVC controller action, returning a view generates an HTTP response with content type text HTML, while returning JSON data generates a response with content type application JSON. One of the most important characteristics of HTTP is that it's stateless. Each request is completely independent from previous requests. The server does not necessarily remember who you are or what you have done before. This creates challenges for web applications that need to maintain state. For example, how does a shopping cart remember what items you have added? How does a website know you are logged in as you navigate between pages? How do multi-step processes like checkout flows work? To address these challenges, web developers use various state management techniques. Cookies is the first one. Cookies are small pieces of data stored in the browser that are sent with every request to the server. They are commonly used for remembering login state, user preferences, and tracking information. The second one is the session. Session state stores information on the server linked to a session ID, typically stored in cookie. This allows larger amount of data to be maintained without sending it back and forth. Hidden fields, or let's say hidden form fields, embedded data within HTML forms that get submitted with the form. They are useful for maintaining a state through a specific process flow. Query string is the fourth type. Query strings append data to URLs like question mark user ID equal 123. They are visible to users and have length limitation but are simple to implement. Modern applications also use HTML5 technologies like local storage and session storage for client-side state management. The token-based authentication systems like JWT, JSON Web Tokens for secure state management. In ASP.NET MVC, you will work with these techniques, particularly session state and cookies, to maintain state across requests. The framework provides built-in support for these mechanisms. Security is a critical consideration when developing web applications. Standard HTTP is unencrypted, which means data transferred between client and server can be intercepted and read by malicious actors. This is especially problematic for sensitive information like passwords or credit card numbers. HTTPS addresses this vulnerability by encrypting communications using TLS transport layer security or its predecessor SSL secure socket layer. Always use HTTPS for production applications, especially those handling sensitive user data. Beyond encryption, web applications face other security challenges like cross-site scripting (XSS) occurs when attackers inject malicious script into pages viewed by users. ASP.NET MVC helps prevent this by automatically encoding output. Cross-site request cross-site request forgery (CSRF) tricks users into performing unwanted actions on sites where they are authenticated. ASP.NET MVC provides anti-forgery tokens to prevent this. SQL injection attempts to execute malicious SQL commands by manipulating input data. This can be prevented using parameterized queries and entity framework. ASP.NET MVC includes several built-in security features to help address these concerns, including anti-forgery tokens for forms, output encoding to prevent excesses, input validation attributes for models, authentication and authorization frameworks. Throughout this course, you will incorporate these security practices into our applications. Remember that security is not a feature but a continuous process that should be integrated throughout the development lifecycle. Now, let's summarize what we have covered in this theoretical section. We have explored the fundamentals of web applications, software that runs on a web server and is accessed through a browser. They follow a three-tier architecture, separating presentation, application logic, and data storage. We have learned about the HTTP protocol, which is the foundation of communication on the web. HTTP follows a request-response model, where clients send requests and server respond with the requested data or appropriate error message. We have examined the key components of HTTP methods like get, put, post, and delete that indicates the desired action, status codes that communicate the result of the request, headers that provide metadata about requests and responses, content type that specify the format of the data. We have also discussed the stateless nature of HTTP and strategies for maintaining state across requests, such as cookies, session management. Finally, we touched on important security consideration, including the need of HTTPS and the protection against common web vulnerabilities. These concepts, these concepts form the foundation of understanding ASP.NET MVC, which we will start exploring in the next section. The MVC framework provides a structured approach of building web applications on top of the HTTP protocol, handling many of the details automatically while giving you control when needed. Okay, we reached the end and bye bye.